we are going to prove that it's a PMF. We prove the mean and also the variance. The negative binomial we have here starts from here, k minus 1, r minus 1. Then here we have 1 minus p to the power. Here the p is the success and 1 minus p is the failure. So negative binomial aims at getting the number of trials up to the kth time, up to the kth success. So we have 1 minus p to the power k minus r, then p to the power r. So here we let k minus r be equal to x. It means our k is equal to x plus r. But here we know that k is equal to r. So if the value is the same and you subtract a value from a value which is the same, you get 0. It means our x is equal to 0. So the probability of a negative binomial is a discrete. That's why we use this. So it ranges from x is equal to 0 to infinity. We substitute for k. This will be x plus r minus 1. Here r minus 1. Then 1 minus p to the power x and p to the power r. This p to the power r, the success, is not affected by the x. The x is the variable that affects the distribution. So this is like a constant. So we pull it out. We have PR. We have infinity. X is equal to 0. Have x plus r minus 1. R minus 1. We have 1 minus p to the power x. So we have this. So we are going to let W be failure and 1 minus W be success. So we are going to use from this expression, which is x is equal to 0 to infinity, k plus r minus 1, r minus 1. Here we have 1 minus W to the power r and k, W to the power k. Here we are saying this to the power r because this is the success, this is the failure. We already know that this is equal to 1. So we divide by 1 minus W to the power r both sides. So we shall have x is equal to 0 up to infinity. Have k plus r minus 1, r minus 1, W k is equal to 1 over 1 minus W r. So here, this expression is just similar to this one. So we consider x is equal to 0. We have x plus r minus 1, r minus 1, 1 minus p, the power x. So here, we substitute for W, we put the failure here. So the failure, we have 1 minus p to the power r. So this is the same as saying 1 minus 1 plus p to the power negative r. But we know p, this will become 0 and you have p to the power negative r. But we just considered this, it came from here. It means that p of x is equal to small x is equal to PR multiplied by P negative R, which is the same as PR plus negative R. P to power 0, and we know that any number to power 0 is 1. Of negative binomial. Negative binomial. We know that the expectation of any distribution is that x multiplied by the p, x is equal to small x. So we know that here we are going to define, we know 1 minus p. Here we are going to define 1 minus p as the success and p as the failure, because the negative binomial aims at getting the number of trials. So our p x is equal to small x will be x is equal to 0, infinity. We have changes from here. Then this, we have x plus r minus 1 here. We shall have 1 minus p to the power r and p to the power x. So here we can't find the success is fixed. So we have to change the mean. We should not include the mean of 0. So we shall multiply 0 with the corresponding probability. X is equal to 0, infinity. We have this as x plus r minus 1, r minus 1. Then this is 1 minus p. This is the expectation. Minus p to the power r, p to the power x. Then plus x is equal to 1, infinity. We have x plus r minus 1, r minus 1. Then you have 1 minus p to the power r, p to the power x. So we are going to, this is a combination. We are going to expand the combination. So we know that this is the same as, you know that this is the same as x is equal to 1 to infinity. We have x, this is x plus r minus 1 factorial. We have r minus 1 factorial. We have x plus r minus 1 minus r minus 1 factorial. This is the same as 1 minus p to the power r, p to the power x. So we have this. This will give us x is equal to 1, x plus r minus 1, infinity. We have x factorial. Then we have r minus 1 factorial. Then we have 1 minus r, 1 minus p to the power r, p to the power x. So you know x factorial can be expanded like x minus 1 factorial. So we shall replace and say x is equal to 1, x plus r minus 1 factorial. We have x minus 1 factorial, r minus 1 factorial. We have 1 minus p power r, p to the power x. This goes with this. So we are left with this. X is equal to 1 to infinity. We have x plus r minus 1 factorial, x minus 1 factorial, r minus 1 factorial, 1 minus p to the power r, p to the power x. But we know that 1 minus r, 1 over 1 minus r factorial is the same as r factorial, because when you expand r factorial, the r's go. And we also know that p to the power x is the same as p x minus 1 multiplied by p, because of the laws of indices. If you apply them here, the x goes back here. Then we know that 1 minus p to power r is the same as 1 minus p r plus 1 into 1 minus p to power negative 1. Because when you also apply laws of indices there, you go back to that. So this will give us x is equal to 1. Yeah, we are going to substitute for what we have considered. This will be r factorial, x minus 1 factorial. This will be p x minus 1. Then we shall have 1 minus p power negative 1 into 1 minus p r plus 1. We remove things that are not affected by x. So we shall remove rp and 1 minus p to power negative 1. So here we shall have x is equal to 1. Then here we shall have x plus r minus 1 factorial, r factorial, x minus 1 factorial. We have px minus 1. We have 1 minus p r plus 1. So we have this. This is a constant. So anything you change with x, this will not be affected, but this will be affected. We first consider this. X is equal to 1. Then we have x plus r minus 1 factorial, r factorial, x minus 1 factorial, p x minus 1, 1 minus p r to power 1. So we know this is defined as our failure. This is defined as our success. So I let w be equal to x minus 1. Then s, let it to be r plus 1. So it means x will be equal to w plus 1 and r will be equal to s minus 1. So from there, we proceed. From the step, we substitute, and this will become x is equal to 1 up to infinity. We substitute for x and we substitute for r. This will be w plus 1. This was x is equal to 1. But if you substitute w plus 1 is equal to 1, you will get w is equal to 0. So even the limit changes. Plus s minus 1 factorial over this will become s minus 1 factorial. This will become w plus 1 minus 1 factorial. This will become p to the power w. This will become 1 minus p to the power s. So this will change to w is equal to 0 up to infinity. This will become w plus s minus 1 because this one goes with this one. This will be w factorial s minus 1 factorial. Ability w 1 minus ps. So if you see this is the expansion form. This w plus s minus 1 factorial and w over w factorial s minus 1 factorial is the expansion form of w plus s minus 1 s minus 1. So when we substitute w is equal to 0, this will be w plus s minus 1 s minus 1 pw 1 minus ps. This will be equal to 1 because it's a probability mass function. So, but we just considered this. So we shall say the expectation is equal to rp 1 minus p to power negative 1 times 1. The one that we've obtained from the expression. That means rp times 1 over 1 minus p will be equal to rp over 1 minus p. This gives us the mean of a negative binomial distribution. So we know the formula for variance of every distribution is E expectation of x squared minus the mean itself squared. So here we have to obtain this. Though the mean is already known that it's rp over 1 minus p, we need to get this. So this is what is required. and we are going to use 1 minus p as our success and p as our failure. So we shall say this will be x is equal to 0. Here we have x squared, x plus r minus 1, r minus 1. Then here we have 1 minus p to the power r and p to the power x. But we don't need 0 in our variance because we are getting the number of trials. So you get x squared multiplied by the p of x. So we are going to get 0 squared. We multiply it with x plus r minus 1, r minus 1, 1 minus p to power r, p to power x. Then we add from x is equal to 1, we have x plus r minus 1, r minus 1. Then this is 1 minus p to the power r, p to the power x. So we have this, we know this is binomial. We shall have x is equal to 1. We expand this combination, x plus r minus 1 factorial r. We have r minus 1 factorial. Then you have x plus r minus 1 minus r minus 1 factorial. We have 1 minus p to power r, p to power x. So this will vanish the r. This will cancel with this and this will cancel with this. So we shall have x is equal to 1 up to infinity. I have x plus r minus 1 factorial. We have x factorial. We have r minus 1 factorial. We have 1 minus p to power r, p to power x. I know x factorial is equal to x minus 1 factorial. So we substitute, we've just expanded here. We substitute it with x factorial. We substitute it with x factorial. So this will be x squared, x plus r minus 1 factorial. We have x minus 1 factorial. We have r minus 1 factorial. We have 1 minus p r, p to power x. This x goes with one of the x's there. So here we know that 1 r minus 1 will become r factorial. We know that p to power x will become p x minus 1. This when you add, you will go back here. So we have 1 minus p to power r. This will become 1 minus p r plus 1, 1 minus p negative 1. This, when you also apply laws of indices here, it changes. So the expectation of x squared will become x is equal to 1. This will be x. We have xr, x plus r minus 1 factorial. This is r factorial. We have x minus 1 factorial. So here we have 1 minus p r plus 1. We have 1 minus p negative 1. We have p x minus 1. We have p. We remove out things that are not affected by the x variable. So this will have r p, then 1 minus p negative 1. This will give us x is equal to 1. Here we have x is equal to 1. Here we have x plus r minus 1 factorial. We have r factorial. We have x minus 1 factorial. So we put the remaining values here. 1 minus p r plus 1. Then we have p x minus 1. So this is no longer affected by this. We are going to first consider We are going to first consider x is equal to 1. We have x plus r minus 1 factorial. Have r factorial. X minus 1 factorial. Have 1 minus p r plus 1 p x minus 1. Let's consider this. So we are going to let this, we know this is the failure, this is the success. So we are going to let w be equal to x minus 1, s be equal to r plus 1. So it means our x is equal to w plus 1, our x is equal to w plus 1, and our r is equal to s minus 1. We substitute them there. So we have x is equal to 1, w plus 1. Here we have w plus 1 plus s minus 1 minus 1 factorial. We have s minus 1 factorial, and w plus 1 minus 1, it will become w factorial. So we have this as 1 minus p to the power r plus 1s, then p to the power w. We notice that this will go x is equal to 1. We have w plus 1, have w plus s minus 1 factorial. We have w factorial s minus 1 factorial, 1 minus p s p w. So we are going to split this into two parts so that we get x is equal to 1. We have w, and this will give w plus s minus 1 factorial, w factorial s minus 1 factorial. We have 1 minus p to power s, p to power w, then plus x is equal to 1, multiply 1 here, then we have w plus s minus 1 factorial, w factorial s minus 1 factorial, 1 minus p to power s and p to power w. This, we notice, is a probability mass function, which gives us the 1. So we have x is equal to 1, w plus s minus 1 factorial, w factorial s minus 1 factorial, 1 minus p to power s, then p to power w plus 1. So we just considered this case. Now let's consider this second case. Consider this. w plus s minus 1 factorial, w factorial s minus 1 factorial, 1 minus p to power s, p to power w. We notice this is the expectation in terms of w. We know that the expectation in terms of x is rp over 1 minus p. So the expectation in terms of w will be sp over 1 minus p. So this will be this. Then it means this is equal to the value of s. We know s is r plus 1. We know s is r plus 1. So we shall say r plus 1 into p over 1 minus p, which is the same as pr plus p over 1 minus p. This is this. But remember, we obtained it from, we had to add 1 and multiply it with this. So it means this expectation of x squared will be rp 1 minus p to power negative 1 will be pr plus p over 1 minus p plus 1. So this will be rp 1 minus p power negative 1. This, you get the LCM. This will be PR plus p minus plus 1 minus p over 1 minus p. So this p will go with this. We have RP over 1 minus p multiplied by, this is PR minus p minus 1, PR plus 1 over 1 minus p. This died with this, so we remained with 1 and this. So this will give us r squared p squared plus r squared p over 1 minus p squared. So we have rp over 1 minus p is equal to pr plus 1 over 1 minus p. So we multiply rp both sides. We have r squared p squared plus rp over this. So this is ex squared. But you know variance is equal to ex squared minus ex squared. So you get this minus this. We have already got the value of r squared p squared plus rp over 1 minus p squared. This is the value of ex squared. Now we subtract the mean squared. This means this will give us r squared p squared plus rp minus r squared p squared over 1 minus p squared. This we squared and we've got the LCM. This goes away with this, so rp 1 minus p squared. So this gives us the variance of a negative binomial.